Hello, this is OCR Further Statistics. We're in Probability Section 1, Arrangements and Selections, and the first video on counting. There are several points where it's a good idea to stop and work some things out for yourself. Whenever you see this symbol, pause the video and try to answer the question before continuing to watch. At this restaurant, there are only 4 main courses available and 3 desserts. How many different meals can I order? Pause the video while you work this out. OK, there are 4 options for the main course, which I've abbreviated to 4 different letters, but not A, B, C, D. I've used letters which will help me remember what they stand for. I've abbreviated the 3 dessert options in the same way. Now, if I have F first, I can follow it with S, or with I, or with C. Similarly, if I have B first, I can follow it with S, or with I, or with C, and so on. So that's 4 different first courses, and for each one, there are 3 different desserts. So that's 4 times 3, which is 12 different meals. This is an example of the product principle. The number of ways of choosing from A and from B is the number of ways of choosing from A times the number of ways of choosing from B. OK, here's a slightly bigger menu. There are 2 types of first course, categorised mains and pizzas. Pause the video while you work out how many different meals you can order now. OK, there were 4 mains and 3 pizzas, so that's 4 plus 3, which is 7 options for the first course, and for each of them, 3 options for dessert. So as before, I can have FS, FI, FC, BS, BI, BC, and so on. But this time I can also have the pizza options followed by the 3 desserts. So I've got 7 options for the first course multiplied by 3 options for the second, giving me 21 different meals. This is an example of the addition principle. The number of ways of choosing from A or from B is the number of ways of choosing from A plus the number of ways of choosing from B. These rules should seem familiar to you. They're very closely related to the addition and multiplication laws in probability. I have a 5-volume course on statistics on my bookshelf. How many different ways can I order the books? Pause the video while you think about this. OK, this time I need all 5 options, but the order matters. There are 5 choices I could choose for the first volume, but then there are only 4 books left for me to choose for the second, and 3 for the third, 2 for the fourth, and then there's only 1 book left at the end. So that's 5 factorial arrangements altogether. OK, can we generalise this? I have n volumes now. How many different ways can they be arranged? Pause the video while you have a think. OK, I've got n books for the first choice, and then I've got n minus 1 books left. So that's n minus 1 choices for the second book, and n minus 2 choices for the third book, and so on, all the way down to 1 final choice for the last book. So That's n factorial arrangements altogether. If you're not already familiar with this, you may want to pause the video to make some notes. Okay, I have too many books. I can't fit them all on my shelf. How many different ways can I choose 3 of them to go on the shelf? Note that order still matters here. Pause the video while you think about this. Okay, I still have 5 choices for the first book, and then 4 for the second, and then 3 for the third. But then I stop choosing, so that's just 4 times 5 times 3. So let's generalise again. Now I have n volumes, but I only have space for r of them on my bookshelf. Pause the video while you work out how many different ways I can do this. Okay, so I've got n choices for the first book, then n-1, n-2, and so on, all the way down to n-r-1. I can write that a little bit more simply. As n minus r plus 1 without the extra brackets. You can write this more simply still using factorial notation. What I've got is the first r terms of n factorial. So we've got the last n minus r terms missing. So if I take n factorial and divide by n minus r factorial, I'll get exactly the terms I want. Now we've got this formula, it suggests another way of counting. As before, when we were arranging all the books, there are a total of n factorial arrangements. But for the last n minus r books which won't fit on the shelf, they might as well all be the same. That's n minus r factorial arrangements that are the same. So I divide my total n factorial by n minus r factorial. Again, you may want to pause the video to make some notes. Okay. To finish, here's a problem to take away. Pause the video to make some notes and spend some time investigating this situation before you watch the next video in the section. That's the end of this video on counting. The next video is on combinations and starts with a discussion of the final problem from this video.